All right, you ready for this? So now we're going to do linear air friction. It's still not quite realistic, but it's not too bad either. Maybe. We'll see. So now we're going to add in this kind of shape parameter times the velocity in that direction, okay? So we've got d squared x dt squared, so the acceleration in the x direction. Instead of being 0, now we're going to give it a drag coefficient, and it's going to be based on the velocity in the x direction times the shape parameter. And in the y direction, we have the negative gravity still, and then we've included in the negative b and the velocity in the y direction. You'll notice that we want b to be positive, so that if we're going in the positive direction, the drag coefficient is opposite of the direction of motion, okay? And so we're going to go ahead and go solve this system of equations. If you've had differential equations, this should be a snap. If not, then just bear with me for a moment. And I might speed this up a little bit. So the first thing that we're going to do is go ahead and just write out the first one. Let's go try to solve x double prime, that's what our d squared is, right, equals negative b x prime. And this is going to turn into a homogeneous second order differential equation. You could actually solve it using just standard calculus methods, but you have to go through a little more work. So we're just going to go ahead and do this. So plus bx prime equals 0, and we can use a characteristic function. So the characteristic and those of you that have taken differential equations should identify that's going to be a lambda squared plus b lambda equals 0. We could factor that, right? So that equals lambda times lambda plus b. And that indicates the lambda equals 0 and b. Now, let's go ahead and put in some initial conditions. We will use the initial conditions that, okay, so let's go ahead and set in our initial conditions of x at 0 is going to be 0, y at 0 is going to be some value we're going to call y naught. And similarly, right, we can do this again with x primes and y prime. So x prime at 0, y prime at 0. Our initial condition and the derivative is going to be v naught cosine theta, and this one's going to be v naught sine theta, right? Okay. Okay. So let's go ahead and try to solve this. So using our characteristic equation, we see right away that x of t equals e to the 0, so that's going to be 1. So I'm just going to have c1 plus, and then c2. These are two constants to be determined. E to the negative bt. That's going to pose a problem later in life, we're going to learn, but that's all right. Actually, later we're going to learn the bisection method, and then you can come back and solve this. All right, but, you know, it'll be cool. So we've got our x. Let's go ahead and take a derivative and set it up for initial conditions. I'll do that now. Okay, so we set up our function. We set up the derivative. X is 0 equals 0. That gives me the two constants are equal to the negative of each other. We set x prime equal to 0. And that sets up that we're v naught cosine theta. That allows me to solve for c2, which gives me C1 is the negative of it, and now we've got our solution here. Okay? And so now we have an X solution. Let's go do the same thing for Y. So let's set up our Y. This one's going to be a little more tricky, all right? I'll just be honest, because it's non-homogeneous. The G in there, the constant, right? So however we want to solve this is up to us. I think that what might be easiest, we could have done this on the last one, so we'll go ahead and do that here. Let U equal, so let's do a U substitution, and U is going to be Y prime, right? So that's going to give me that what? That U prime equals Y double prime. And off of that, that'll let me reset this up to U prime equals negative G minus B times U, right? So now I have something that maybe I could manage, and let's rewrite this, okay? So let's rewrite it as du dt. Those of you that have only taken Cal 1, okay, follow me here. If you've taken more advanced than that, you might have some other methods of dealing with this. You might have dealt with it like the one above, kind of. Okay, so you see how I have this? I'm going to move the dt to the right-hand side, and I'm going to divide all of this stuff to the left-hand side. Okay, you follow me? So now I'm going to get a new fraction on the left, and it's going to be du divided by this stuff, right? I'm going to call it G plus BU, and I'm going to leave the negative on this side, as weird as that sounds, okay? And I just chose to do that. I could have done a lot of things. And what we're going to do is we're going to go ahead and set up our integrals of both sides. So we're going to integrate the left-hand side, which looks like a natural log, doesn't it? So that might be cool. And then we're going to integrate the right-hand side, which looks easy, because I can integrate -1 just fine. All right. Okay. On the left-hand side, I'm going to have a natural log of that denominator, aren't I? And I'm missing a constant out front. Let's go figure out what our constant is. So it's going to be G plus BU. Okay. So when I take a derivative of this, I'm going to multiply by B. So I'm going to take a 1 over B. So that should be the integral of this. You could take a derivative and double check yourself. And on the right-hand side, I'm going to get -t plus C. Okay? And there's my first constant of integration. Now, we need to go solve for that U, so let's go ahead and multiply by B, okay? Now, B is a constant, right? C is a constant. So when I multiply B times C, here, this is going to drive you nuts, so maybe not. So I'm going to name that C naught, okay? Follow me here. So I'm going to multiply by B, okay? Okay, so here we go. I've got the natural log equals, oh, don't do that. Okay, this natural log equals negative BT plus, but B is a constant, C is a constant, so when I multiply them together, I get a new constant. I'm going to name it C1 now, okay? Did you follow me? Now, I'm going to raise it to E. So I'm going to get just this stuff inside, G plus BU, and that's going to equal E to this whole right-hand side. Now when I do E to the whole right-hand side, what's going to happen is I'm going to split these two guys up, right? So I'm going to get E to the negative BT, and then E to this new constant, which we named C1. But E is a constant, C is a constant. When I raise a constant to a constant, it's a constant. So that means we're going to rewrite this as this equals, okay, so now we're going to name this thing C2. It's my new constant, right? And then E to the negative BT. I can't do that with that, right? Because it's got a time variable in it. It changes. Okay, so now this G is a constant. Let's move it over. We're going to divide by B. So let's go ahead and solve for U itself. So U equals, and it's going to be this minus G, and then all divided by B. Okay, C is a constant, B is a constant. When I divide the two, I get a new constant. I'm going to name it C3. And then I got e to the minus bt. But now I have negative g over b. That is a constant, but don't do it, right? We can compute that. Okay, so cool, we got that. Now we've got this by itself, so let's go rewrite this without that middle stuff. Okay, so that's the derivative. So this is y prime is going to be that, right? And we know that y of 0 is this. So let's go ahead and plug that in and solve for this constant of integration. So that would equal, I changed my mind, that equals, if I plug in 0, e to the 0 is 1. So I just get this constant minus gb, right? And so C3, this constant, after all of this mess, whatever the constant is that we've been messing around with, that's why I kept renaming it. It didn't really matter. We were going to get to the same thing no matter what. And it's going to be this term plus this here, okay? And so now let's go ahead and rewrite our y prime and set ourselves up for our final integration. Okay, so when we plug in our constant and then we set ourselves up to integrate that, we can integrate it directly. This is just an e, and this is just constant, and then we get a new constant of integration. Let's go ahead and plug in our initial condition now, so we know that y of 0 is y naught. And from here, we can actually solve this. We'll get y naught equals, and the e to the 0 is 1, and this term is going to be 0, so we just get this plus our constant. And we could definitely clean this up, right? So we're going to move this over and clean it up just a little bit. And C equals, I'm going to move these B's together. So I'm going to get like, I guess, y naught plus, and then now this thing divided by B. And then this thing over b, so that's going to be g over b squared, right? Okay, and now we have our new constant from the integration, and so we have y itself. And this is why the elimination of the parameter was cool in the last one. We got rid of the time and we could actually see the parabola, but here you cannot. Well, maybe you can, but you'd be working all day for that mess. Okay, so it's going to be this. Hey, you know, this might clean up. No. It just gets worse and worse. Fantastic. Okay. So we have our x and our y from this model, and without any constants of integration. So we're actually in pretty good shape here. As messy and terrible as this is, we can make the computer do the work for us, which is awesome. Okay, you ready? You're going to go code this. So compare this now against your ballistic using the error.